Hello everyone. So today we will do 5.5, that's a performing function operations. Whatever the radical equations or functions we learn, now we are applying operations on it. What type of operations? Addition, subtraction, multiply, division and composition also. Okay, so let's do that. First operation I will do addition. Addition is if you have a two function f plus g of some function f. I can rewrite it as f of x plus g of x. This is the first operation, addition. In the subtraction, f minus g of x is equals to f of x minus g of x. Multiplication. In this you multiply two functions, f function and g functions are multiplied and then it's a function of x. I can rewrite it as f of x times g of x. Next is division. F over g of whole x, I can write f of x over g of x. But whenever you divide by something, make sure there is a condition, denominator cannot be 0. So g of x can't be 0. Okay. We can start with the examples. The first example we have fx is equals to square root 3 and g of x is minus 10 square root x. We have to find f plus g. From the definition of addition, we just learn f plus g of x can be written as a fx plus gx because I have a separate two functions, not a combined addition of two functions. But I can calculate. Fx is 3 times root x, gx is negative 10 root x. Simplify. 3 root x minus 10 root x. That's a negative 7 root x. This is the function f plus g of x. What was the domain of f? Domain of f was x greater than equals to 0. Domain of g is also x greater than equals to 0. After addition, I got this and that has a domain again x greater than equals to 0. So basically, what is the difference between the new domain and the original functions? Sometimes some values are not in the domain in original f and g. But when we combine, that value exists. But still we have to remove those values. The answer of the operation, the domain of a function after operation maybe include those domain of functions individual. Domain of individual functions and the domain of function after operation, you have to combine them all and check what is the common answer. Alright, let's do the next one. Okay, there's one more thing they say. Evaluate the sum when x is 4. So substitute 4. X as a 4. Minus 7 square root of 4. What is square root of 4? 2. 7 2s are 14. So negative 14 is the answer. Fx is given, gx is given. We have to find f minus g domain and state the domain. Fx is gx is. So f minus g of x, that is f of x minus g of x is equals to 3x cubed minus 2x square plus 5 minus x cubed minus 3x square plus 4x minus 2. Open the brackets. 3x cubed, 2x square plus 5 minus x cubed plus 3x square minus 4x and plus 2. You can combine the x cube terms, combine the x square terms, combine the terms of only x, and then constant terms. I'm getting this. Okay, so after getting this, let's see the domain. It is a polynomial function. Every polynomial has a domain all real number. In this case, all reals. Gx is also a polynomial, so all reals. What I got after answer, after subtracting, I also got a polynomial. So domain is all reals here again. Okay, done. And then they ask you to calculate the value at negative 2. F minus g at negative 2. 2 of negative 2 cube plus negative 2 square minus 4 times negative 2 plus 7. 2 cube is 8, 2 is 16 minus 16. 2 2s are 4 plus 8 plus 7. Okay. If you add them, what you will get? 8 and 4, 12. 12 and 7, 19. 19 minus 16, 3. So you are getting 3 as an answer. Next is a quotient. It is a f. Okay. F is given, g is given. We have to find domain of a function f over g and then its domain. Let's find f over g of x. By the operation property, fx over gx. 6x, let me write down, over x power 3 by 4. You can shift this term at the top, right? I can shift this term at the top. It will be, this x can be shifted up, so 6x, 1 power was there. When this shifted up, the power become negative. So what you are getting? You are getting 6x to the power 1 minus 3 by 4, which is x power 1 by 4. Now look at the domain. Domain of fx, it's a polynomial, so all reals. And here the power is less than 1. So in this case, it is not exist when you have negative number. But you can also see in x power 1 by 4, then it's cube. When we learn in the last in the chapter of exponential, when we talk about this rational exponent, that's the topic of rational exponent, how to break the rational power in this. This term exists only if x is positive. Therefore, here the domain of gx is all positive number. Positive real number, you can say. When you combine, it has a also the condition, this can be only positive. So what is the total common answer? All real, only positive, and only positive. So common is a all positive. The domain is all positive real number. Okay. We can do the next one. Okay, they also asked for the value at 16. So substitute 16. We can check the value at 16. F over g at 16. 6 times 16 to the power 1 by 4. What is 16? 16 is a 2 power 4. This 4 and 4 cancels, 2 left. 6 into 2. 12. Done. Next. Okay, this question is different. fx is given, gx is given. Use a graphing calculator to evaluate this when x is 2. Round your answer to 2 decimal places. Let's see. If I directly calculate f plus g at x, fx is root x, gx is square root 9 minus x square. Substitute 2. Square root 2 plus square root of 9 minus 4, that is a 5. Square root 2 plus square root 5, you can calculate. this will be 1.41 something, and root 5 is 2.2 something. You can calculate this further. For multiplication, f into g of x, root x times square root of 9 minus x here. Both terms are square root, so you can bring inside. Substitute 2, and if you substitute 2 here, it's a 5. So 5 2s are 10, square root 10. Calculate it up to decimal places, 2 decimal places as they asked. Next is f over g of x. Root x over square root of 9 minus x square. Substitute 2. Square root 2 over square root 5. Calculate. Okay. Now we have a question. It says for a white heart rate in beats per minute and the lifespan s in minutes are related to the body mass by the function Rm. Okay, R is the heart rate. M is the mass. This is the function, how it's spent. The heartbeat is dependent this and the lifespan is this. Question is saying a part, find Rs at M. R is a function of M. S is a function of M. I have to calculate the multiple function. So let's calculate. Rs at M. What is Rm? R at M is 241 M power negative 0.25. What is S at M? 6 into 10 power 6 times M power 0.2. You can multiply. If you multiply them, you will get 6 1s are 6, 6 4 24, 4, 1446 into 10 power 6. M power negative 0.25, M power 0.2. So powers will add, if you add to minus 0.05. This is what you will get in this case. And if you want, you can write the terms in a decimals. So I bring the 3 zeros, 1, 2, 3 into 10 power 9. M power negative 0.05. Okay, so this is Rs at M. Then question say what Rs of M represent. What is the meaning here? Here we multiply heart rate by lifespan. We multiply heart rate with the lifespan. That gives us the total number of heartbeats over the lifetime of a white rhino with body mass M. Okay. So that's just a multiple of heart rate with the lifespan, and that gives us total number of heartbeats. Total number of heartbeats over lifetime of a white rhino. Alright, so we are done up to this. This is 5.5. I hope you understand. Thanks for watching.